Alright, welcome to the Mustang Math YouTube channel. I'm Jacob and I'll be discussing difference in sums of powers. So this is a very interesting topic. In general, what this means is that we want to try and factor like numbers like an minus bn and an plus bn. So we're looking at these kind of factorizations and maybe already are familiar with one like a squared minus b squared. Maybe you know that one. That's a very common one that we call like difference of squares. And in general, those just factor to a minus b times a plus b. Now let's look at some other things. So our introductory question, can you factor a squared minus b squared? We already talked about that, and maybe you've already seen that as well. So you can factor that like a squared equals a minus b times a plus b. This basically just means that you want to find when this is equal to 0, and that's equal to 0 when this equals 0 or this equals 0. Now let's look at a cubed minus b cubed. Notice that when b equals a, this result equals 0. So we can just try to factor out a minus b, and this factors out pretty nicely as a squared plus ab plus b squared. I'll save you the arithmetic, but that factors like that. And a cubed plus b cubed. Let's look at that one. Well, a cubed plus b cubed, that factors when b equals negative a. So we want to find a plus b times a squared minus ab plus b squared. So that factors very nicely as well. So maybe there's something very common that's going on between these. Let's see. So in general, this is what happens. For difference of powers, you have a to the n minus b to the n. You can always factor out a minus b. And when you factor out a minus b, you end up getting this very long system. So like for example, let's say a to the 4 minus b to the 4, you can always factor out a minus b. And what you end up getting is you plug in n equals 4. So a cubed plus a squared b, when you plug in 4 here, then ab squared plus b cubed. So you kind of just decrease the exponent, and then you just keep on going. So you keep on decreasing the exponent of a, and then you increase the exponent b. Okay? Let's look at the sums of powers. So here, I'm saying n has to be odd. You can't really factor a squared plus b squared. When you factor a squared plus b squared, this b equals negative a, and then like this is equal to 2a squared. That's not really equal to 0 all the time. But if it's odd, like we saw in the example before, we saw a cubed plus b cubed, we can always substitute b equals negative a. And this would be a cubed plus negative a cubed, and that's just 0. So you can always factor out a plus b if n is odd. So that's a key part, n is odd. And instead of it just being pluses right here, you actually are alternating. So you have a minus, and you have a plus, and you have a plus here, and minus here, and a plus here as well. So everything is like alternating in this example. So you start off with a minus, then you go to plus, then you go to a minus here, and you go to plus. So it's all alternating. So for instance, let's see, a to the 5 plus b to the 5. This factor, since n is odd, and this would be a plus b times a to the 4 minus a cubed plus b, a cubed times b plus a squared b squared minus ab cubed plus b to the 4. So everything is alternating in this example. So these are two very important facts when you're doing problems. So let's look at an example of how we can apply this. I have this very long sum, 2 cubed minus 1 cubed plus 4 cubed minus 3 cubed plus 6 cubed minus 5 cubed and so on until 18 cubed minus 17 cubed. And we want to find this long sum. This is actually the 2023 AMC 12A number 12. So we want to find this value. Okay, well, let's look at this difference of powers. Difference of powers, let's copy that right here. I don't have this handy. So we are looking at powers of 3, I see, right? We're looking at powers of 3. See a bunch of powers of 3, so let's just plug in n equals 3. And notice we're looking at differences, n cubed, 2 cubed minus 1 cubed, 4 cubed minus 3 cubed, 6 cubed minus 5 cubed. So let's see, so 2, so we have like, yeah, okay. So a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. We saw that earlier. Okay, but notice that we're dealing with, like, if we kind of block each of these. So 2 cubed minus 1 cubed, that's one block. 4 cubed minus 3 cubed, that's one block. 6 cubed minus 5 cubed, that's another block. 18 cubed minus 17 cubed, that's another block. Well, notice that in each of these blocks, you have two numbers, and they're both like consecutive numbers. The difference is always 1. So we can actually carry this to like a, where like you can set b equal to a minus 1. And when you do that, you have 1 times a squared plus a times a minus 1 plus a minus 1 squared. And this ends up being 3a squared. So we can kind of expand this out. 3a squared minus 3a plus 1. So we just have like a sum that we want to compute. Okay, cool. And in fact, we can further say that like we want to find the sum from 2a cubed minus 2a minus 1 cubed, and that would be 1 times 4a squared, so that would be 2a squared plus 2a times 2a minus 1 plus 2a minus 1 squared. This is 12a squared. This is 4a squared minus 2a, 4a squared minus 4a plus 1. So minus 6a plus 1. I want to find the sum as you sum from, you take a equals 1 until a equals 9, right? Because we have, well, 2 times 1 here, 2 times 2 here, all the way until 2 times 9 here. Okay, so we want to find the sum. So we want to find 12 times 1 squared plus 2 squared, and so on until 9 squared. We want to find minus 6 times 1 plus 2 until 9, and then we want to add 9 since there's the 1 happens 9 times. Okay, notice this is 12 times 9 times 10 times 19 over 6. This is basically just 15 here. Try to expand this out. This is, let's see, 112 times 15. That's 180 times 19. 18 times 19, let's see, 18 times 19, 324 plus 18, this is 18 squared. Right, so 342, so 3420. Okay, we have this minus 6, so minus 6 times 9 times 10 over 2, this is minus 3, so minus 270 when you multiply the 3 and 9. And then we have to add 9, so add 9 here. So when you do that, what's this thing? This is 3150, 3159 when you add the 9 to 3,150. So 3159, that's a long sum, lots of computation, but the main part was being able to factor the a cubed minus b cubed into something very nice that we can compute. Okay, so what happens if we toss another variable? This is just a little additional thing that we can see. So let's see what happens when we just add another variable. So we have like a cubed plus b cubed plus c cubed. I want to factor that. This is a very famous factoring. Some may call it the T2's favorite factoring trick, which maybe we'll see something very similar in another video. But yeah, it just factors very nicely. You can kind of take this. You have this a cubed, a plus b plus c. You have this long sum. You have this long sum, and this is kind of very nice because like a squared plus b squared plus c squared, that's also equivalent to a plus b plus c squared minus 3 ab plus bc plus ca. So this is all very, very nice. You can kind of get it into the form where you have a plus b plus c, you have ab plus bc plus ca, and you have abc. So it's very nice factoring that involves these three different symmetric sums. So yeah, very nice factorization. I recommend you memorize that, or at least know it. So yeah, awesome. Hopefully you learn how to apply these different powers, and you learned about this really cool factorization, and you really enjoyed this little fun question that we touched on for a bit. Yeah, hopefully you learned something from this lecture.